If p is an element of R, the real number set, prove that p squared plus 1 over p squared is greater or equal to 2. Well, what we're going to do first of all is try and get rid of the fractions. So since we have p squared in the denominator, we're going to multiply across by p squared. So p squared multiplied by p squared is p to the power 4. And 1 over p squared multiplied by p squared, well, the p squared will just cancel out in the denominator and we'll be left with 1. And that's greater or equal to 2 multiplied by p squared, which is 2p squared. I'm going to bring the 2p squared over the inequality sign. So I have p to the power 4 minus 2p squared plus 1 is greater or equal to 0. I'm going to break apart the minus 2p squared to get minus p squared and minus p squared. I've still got the p to the power 4 and the plus 1, and it's still greater or equal to 0. I'm going to do factorization by grouping, so I'm going to take p to the power 4 minus p squared and factorize them. So I've got p squared multiplied by p squared minus 1. And then I'm going to take minus p squared plus 1 and factorize those. So I've got minus 1 multiplied by p squared minus 1. And that's still greater or equal to 0. Since I've got p squared minus 1 inside both brackets, that's one of my factors, p squared minus 1. I then bring down the p squared and the minus 1 and put brackets around that. So that's my other factor. So I've got p squared minus 1 multiplied by p squared minus 1, which is p squared minus 1 squared, because they're both the exact same. And that's greater or equal to 0. And this statement is true because anything squared is going to be greater or equal to 0. So if this is true, then this must also be true.